So for the first exercise, it says calculate the area bounded by the region of f, which is x to the cube, from the boundaries of x equals -2 to x equals 4. So it is asking for this area. So first we start with the integral. We put a minus for this because it's going to be negative, from -2 to 0 of x3, plus, because this is going to be positive, the integral from 0 to 4 of x3, and we put the x to each one of them, and then we just integrate. This one is going to be minus x4 to the 4 from -2 to 0, plus x4 divided by 4 from 0 to 4. And then we apply the first theorem of calculus, and it's going to be like this. This is the first term for this part. This minus and this minus, it becomes positive, and then this one. And as a result, we get 68.
So in exercise B, it tells us to calculate the volume of the solid in the region bounded by the function the horizontal lines y equals 0 and y equals 8. And it says that the y-axis is revolved about the vertical line x equals -3. So in here we will need to change the x's for y's. So in here the function of x equals x to the cube is the same as cubic root of y. So the equation we will use to get the volume is pi times the integral between 0 and 8 of the function, which is cubic root of y, elevated to the square. So first we need to elevate cubic root of y, which will be we know that y cubic root of y is equal to y to elevated to the 1/3. So in this case we will need to multiply 1/3 by 2, and we will get y elevated to the 2/3, and then we will need to integrate. So we will get, if we integrate this, we will get y to the 5/3, and over this, which is 5/3, between 0 and 8. And we simplify this, which will be 3/5 times y to the 5/3. So then we use the first theorem, and we will need to substitute these values over here. So first we use the number 8. And it's -0 because we have number 0 here, and if we multiply all by 0, we get 0. So it's 0. And then we will have to resolve this. So the value of the volume will be 19.2 pi.
Well, I'm going to explain the exercise C. where you have to calculate the volume of a solid with the vertical lines of x equals to 0 and x equals to 4. It's a cross section perpendicular to the x-axis and it's a square. The volume is by integral from 0 to 4, and our function is x to the 3, and it is a square, in which this made us x to the 6, and when you integrate, you have it like this, and the result will be this.
So for the last exercise, it says to calculate a Riemann sum approximation using the trapezoidal method between the function of f, x-axis, and the vertical lines x equals 2 and x equals 4, using 4 subintervals. This means that we first need to calculate the x, which the x is the biggest interval minus the last one. So 4 minus 2 divided by the number of subintervals. So the x is going to be 0.5. But in the case of time, we use that value half, so 0.25, and we use the first number. It is normal because we are going to use 4 subintervals, so which is 2, 2.5, 3, 3.5, and 4. So we use 2 in the value of f, so to the cube, then the double of the second value, 2.5, to the cube, plus 2 times 3 to the cube, plus 2 times 3.5 to the cube, plus the last number, which is 4, to the cube. This is going to be 0.25, 8 plus 31.25 plus 54 plus 85.75 plus 64, and the final answer of the trapezoidal method is going to be 60.75.